Thanks all for joining us. Thanks obviously to Judy for inviting us. So yeah, this presentation is part of our project at Tate, supported by the Lumen Foundation, to develop a high-level preservation strategy for VR artwork. So yeah, as introduced, kind of moving a little bit more, hopefully towards the nitty-gritty. So just a little bit of context to the project. At Tate, we were starting to use VR tools to capture information about our complex physical installations. And our investigations into stabilizing that information and also experience within the department at preserving software-based artworks had led to Judy contacting us about preserving the artwork, The Archway, which by Don Biddulph, that you maybe saw next door. So we agreed to look at the work in a little bit more detail, and that's when the project started to grow. We were then put in contact with the Lumen Foundation, and Carl and Jack are here today. I think they've been introduced already, who support digital artists through various amazing means. And they had been nurturing relationships with a host of artists working in digital forms, including VR. So they kindly supported the project and, very importantly, put us in contact with artists that they'd been working with. And we were able to interview these artists about their workflow, their practice, their ideas of how their work might be displayed in the future, and also we were allowed to scrutinize the technical aspects of their work. So the support of this project has basically allowed us to move from that exploratory research towards a strategy for acquisition and preservation. So this presentation will kind of summarize our progress so far. Dom will introduce his work, and then we'll reference it where appropriate in the presentation. So I think this is Dom.
Hello, everyone. I'm just going to give a brief introduction to my work, and then I guess I'll be back at the end. Is that the plan? So if you just give me a moment to bring my notes up. The Archway was a work that I produced in 2017 as my final year BA work, and it was also the work that I showed at the degree show. It's a photogrammetric recreation of the Archway print studios. So this is where the silkscreen printing, the litho printing, and etching used to happen. But at the end of that year, they were relocated here to King's Cross. It's built for room scale VR, so that means you can traverse it naturally. And it was built with Hammer and Source Engine 2. It's the game engine and the tool set that I used to build it. But Jack and Tom will talk about the kind of technicalities of that later on. I built this in response to the fact that it was moving, and this was a space that I was quite familiar with and quite fond of. So the idea of having a way to visit this again, albeit virtually, was really important to me. Because it would have been sad to kind of say goodbye to it and then it be gone. It's very distinct from other workshops. It had a particular kind of quality to it. There was a lot of dirt and paint and build-up from years and years of use. And actually this made for a really great subject for photogrammetry, because photogrammetry, which is a process of generating 3D models from photographs, really, really loves textural details to generate the space. So it was a nice kind of marriage of those two elements. So as I mentioned before, this was a work that I showed for my degree show piece, and I saw this as an opportunity to invite visitors to a space that they probably had never had a chance to visit, or perhaps they'd never even visited a print studio of any kind before. So I kind of saw this as an introduction, an education to the kind of space that most students produce work in. And I was from the graphic design course, so a lot of my cohort were producing screen printed works. So to give a kind of reference point to how those processes were built. Shortly after the degree show, the work was purchased by the school and the museum and archive. And this began a really interesting conversation around how to preserve this work. And it was a work that began it came from preserving a physical space, and it became a digital work. And then this digital work was at the center of a conversation around how to preserve those in a physical space as well. What do you do with that data and the drives and the hardware that that's stored on? I'm going to pass you back to Jack and Tom, who are going to dive into the technology.
Thanks. So just by way of starting, here's a bit of a system overview. So just to kind of introduce some terms of reference. So basically what we wanted to show in this diagram is that the user forms an important part of the VR system. The headset that the user is wearing is receiving images generated by the computer, but it's also monitoring the movement of the user's head and feeding back into the computer, determining what part of the image we see, what audio we hear, etc. There's also positional tracking in various forms, which uses a relationship between the headset and external sensors to generate a position within the physical space that the user's occupying. So within the computer system, there are a few important software components to highlight. The VR application is key to the preservation, and that's the bespoke software and associated data. And this application communicates with the specialized VR hardware via what is known as VR runtime. And that's a software component usually provided by the manufacturer of the VR hardware. And that incorporates various APIs, drivers, and handles the various ins and outs of the communication with the headset, between the headset and the computer.
So in the next few slides, we're going to continue to develop these kind of terms of reference for the kind of digital materials that we're dealing with when acquiring a work like VArchway. And yeah, I wanted to start by introducing the kind of production materials that would be generated during the process of creating a work like VArchway. So the environments we experience in real-time 3D VR, which is the kind we're talking about here, frames generated in real time rather than in some predetermined form like 360 video. These experiences are built using assets which are brought together in a 3D engine. So the assets are the things that fill the environment, the 3D models and their animations, textures mapped over the surface of those meshes, things like sound effects. And so assets have their own workflows associated with them, tools and workflows independent of the game engine which they're brought together in the final stage of the process. And the engine itself is a super complex program for constructing 3D scenes. So these programs are kind of monolithic. They implement a huge array of things like lighting algorithms, material shaders, physics, scripting, the list goes on. And there's an array of different engines in popular use at the moment, but kind of Unity and Unreal are probably the big two for real-time 3D VR at the moment. But there are many others, and VArchway is a work which uses an engine called Source. So working with an engine today usually looks kind of something like this. This is actually a screenshot of Don's project for VArchway, open in Source Engine 2's Hammer editor. So you get a kind of visual interface which allows you to manipulate the scene through the viewport in the middle. Assets are arranged, imported and lit. Cameras and scripting are created to add kind of dynamics and interaction. And then finally everything can be packaged at the end as software. So the built VR software which you end up with is some variable mix of a compiled low-level code and the packaged data assets. So as such, we're not really dealing with file formats in the typical sense. These are very opaque files. Software is usually built for a particular processor type and operating system. And whenever the application is executed, this complex system of hardware and software is engaged. So we've kind of broken the layers of this system down into three parts. So there's the VR runtime, which Jack already briefly talked about, which handles the communication between the VR hardware and the host system. There's a graphics API, which handles the communication with the graphics card and the specialized processing that bit of hardware does. The graphics API is more between the host system, the operating system, and the graphics card. And the GPU itself, which is the physical device, which carries out the graphics maths and it's usually associated with manufacturer-specific drivers. So these layers all potentially introduce specific characteristics that affect the resulting VR experience. So they're kind of super important to monitor when looking at the preservation of these artworks. And the VR runtime is, I think, something that's emerged as particularly significant for us. And it was associated with manufacturer-specific features like lens distortion is one good example. The thick lenses in VR headsets distort the image so that it achieves a maximum field of view around the eye when it's close to the eye. So the software transforms the image sent to the headset screens so that this distortion doesn't distort the actual content of the image. So that's just one example. So that's kind of our terms of reference. I'm going to pass back to Jack, who's going to introduce our preservation considerations.
Thanks. So yeah, as we touched on before, we'll just look at existing time-based media preservation strategies and look at how they might apply into VR and also to Dom's work. So just to run through them briefly, and we'll go through these in a lot more detail. We could store the hardware. That's obviously very short term. We could change to a new headsets or computer in the case of migrating hardware. We could emulate hardware, which would be to run our old software in an emulated environment on new hardware. We could migrate software. And in VR, there's a few different ways in which we could think about that. That really branches out, and Tom will go into that in a lot more detail. And we'll also look at the complexities of documentation. So just very briefly, I guess to use a time-based media analogy, we would store CRT monitors, for instance, and we would stockpile as many of those as we could, and they might start to break, and they would get harder to maintain, more expensive to maintain, but we might consider keeping multiple instances of the hardware. And we're interested to sort of, investigate what the kind of lifespan of that might be. So we'll maybe start to look at, what would cause a VR headset to deteriorate. Should we store it and not use it? I think they deteriorate very quickly if used.
So yeah, assuming the assumption being that these physical systems will become impossible to, will fail and become impossible to replace or repair at some point, kind of think about what we can do. One approach would be to switch to a new hardware system, and this raises a bunch of questions. So there's lots of variability in hardware between the headsets, between the tracking systems, and between this manufacturer-specific software, which I've already mentioned. And this makes it possible that the experiences, the characteristics of a VR experience might change if that hardware is changed, so introducing a degree of risk. And I guess it's also worth saying that while there might be undesirable changes like things breaking, there's also the potential for what artists might view as more desirable changes, so higher resolution images in a newer headset. So this kind of change also introduces more practical issues, which limit kind of the potential of this particular strategy. So if software was built for a specific graphics API or a specific VR runtime, and it often is, it might not work at all on newer hardware. So the VR runtime being super important within this, we were wondering whether there's been any attempt to kind of standardize these runtimes, which would potentially lower some of this risk. Currently, the world of VR runtimes is super fragmented. And there's lots of work required to make sure a particular VR application can work well on multiple headsets. So people tend to design for a particular one, and the artists we spoke to during this project all seem to have designed their work for a specific headset and VR system. So OpenXR is an industry standard kind of at the early stages of development, which would offer an open specification for VR runtimes. And this promises to provide a generic kind of open interface between VR applications and the devices. So this could make changing at the hardware level relatively trivial. We'd still be reliant on the backwards compatibility of the runtime, so that old applications will be able to talk to new hardware through the runtime. But if OpenXR were implemented for if support for OpenXR was added to vArchway, for example, this would open up more hardware migration options in the future. Unfortunately, it's really contingent on how the standard develops. whether it's adopted widely and general industry whims. So, we're really conscious that we definitely need to think about other options. So if we can't migrate hardware, another approach might be to run old VR applications on newer hardware through an emulation layer. So this would push back obsolescence by simulating the obsolete hardware. And this works really well. We already know from the countless case studies in type-based media conservation and software preservation. This works well if you want to run old applications on new PC hardware, for example. However, this doesn't work particularly well where peripherals are involved. And as we saw earlier in our system overview diagram, there's a lot of peripherals involved in these VR systems. So that's a real limitation. Also, the support for graphics emulation in general at the moment is very limited, which makes achieving reasonable frame rates pretty difficult without using certain specialized techniques that then lower the preservation use of this particular strategy, which I won't go into more detail on power virtualization and pass-through here, but there'll be things that we'll be talking about in the outputs of the project in more detail. So yeah, we found emulation a bit of a dead end for now. It definitely holds promise, and it's definitely going to be a useful tool for other things, which we'll come back to towards the end of the presentation. But yeah, for things like accessing old production materials and old engines. So a more drastic option would be to consider making changes to the software itself in order to keep it running. So on one level, this might happen incrementally as a particular project is updated to use new versions of the engines, platforms, and runtimes on which it relies. This raises questions about how frequently this would be done, and it's kind of interesting to imagine digital preservation as more of a maintenance activity here. So yeah, artists seem to be managing this themselves at the moment, and Dom and others we've spoken to have all had to carry out various kinds of incremental update to keep their artworks accessible. So if this kind of incremental approach becomes impossible, then we're looking at something even more drastic, like moving to a new platform or a new engine. And this probably raised the most questions for us, many of which we haven't been able to answer yet within this relatively small research project, but it's certainly interesting grounds for further research. So a few of the questions which came up, how time intensive would it be to migrate a VR artwork project to a new engine? And how feasible would that be without losing characteristics, perhaps specific to that engine, that really make that artwork what it is? We considered issues about whether open source engines would make this any easier. Unity and Unreal Engine now both offer access to source code repositories under certain license conditions, which is definitely going to be help with this kind of work. But there are further issues caused by some occasional connections between projects and online resources. So many of these engines are now tied up with asset stores and the licenses associated with a particular account, which makes kind of disentangling them from that all the more difficult. And assets I'll come back to in a second. But yeah, I guess just a quick comment on vArchway and Dom's work. Dom expressed from the outset an interest in the potential for remaking vArchway in the future. So CSM will be getting all the original production materials, including the photographs that Dom took and transformed using photogrammetry. So there is the potential to rebuild this work using other technologies in the future. So yeah, we have standards for preserving things like sound, video, and 2D graphics now. There aren't many universally agreed single standards, but we have approaches for this kind of thing. So we were wondering whether there were similar standards available for preserving 3D models, some kind of way of stabilizing 3D model files. And we found a massively fragmented landscape, many different file types with different purposes related to specific fields, and standards which have kind of struggled to keep up with the rapid evolution of the industry. So kind of what's required of a 3D object is always changing and evolving, which makes this kind of standardization super difficult. And we've seen this in various standards which have fizzled out over the years, the Collada file format, Universal 3D or U3D. So in practice, and speaking to artists, we found people rely on source project files of whichever programs they're using to do things like modeling, and then often export as a proprietary file format called FBX to get that file into an engine. And that's really become a de facto standard for newer engines like Unity and Unreal Engine. It's difficult to see people adopting an alternative right now, but there are a few interesting standards, maintained standards, which we are looking at, the X3D standard and the GLTF standard, which is the latter of which is very new, but very promising, both open specifications. So yeah, there's more research needed on these tools, on these formats to test whether they capture all the kind of significant properties associated with a particular 3D model. Also worth highlighting, the Library of Congress are doing some great work publishing file format sustainability reviews for some of these. Their X3D review is coming out in the next few months, I think. So for the last bit, I'm going to pass back to Jack.
Thank you. Yeah, so we, in discussion with the artists that we've been working with, we started to discuss what kind of technical documentation we should be gathering that may prove useful for making preservation decisions. And we've been, like sort of part of the project we've been doing is kind of working on the sort of outline, a sort of template of a kind of form that might serve use at the point of acquisition. And I think as part of the project outcome, I think we're thinking about sort of making that available to those interested. We have been thinking a lot about display specifications, and that's something I guess that we're familiar with within time-based media conservation for video works or installation works, kind of defining the parameters of how an artwork might be displayed in the physical gallery space. But that becomes really sort of convoluted in an interesting way when describing a work's physical presence in the gallery, but also its characteristics within the virtual aspect of the work. We've been thinking a lot about how you could capture aspects of the work for a documentation point of view. We've been thinking about capturing the point of view of the user in the virtual environment. Sort of capturing somebody's experience. And this could be perhaps in conjunction with an external camera, which would be capturing their movements. And I was chatting to some people earlier on that were saying how interesting it is seeing people in the virtual world from the outside. And that's I think of historical interest for institutions that are collecting these works, is to see how people are actually interacting. One form of capture is, obviously you can capture stills, you can capture 2D video. You can also render as 360 videos from these 3D engines. And if you imagine a virtual reality experience which is on rails, that is, you're sort of led around the experience, then a 360 video capture becomes some documentation that's actually quite close to the experience of the work. But for an interactive artwork, then obviously that's missing a layer of interactivity. And a 360 video export would perhaps form as some sort of documentation, perhaps for curatorial access, more accessible than setting up the full interactive experience, but still delivering some aspect of the immersion of the work. So I think these are some of the things that we're exploring, is the sort of documentation of these works can take on various forms and deliver varying accuracy, some of it close to the artwork, some of it not. So we were kind of interested to say, at a minimum, what can we do now? What can we do as collecting institutions? We were kind of predicting, some of you might say or something, what about if we collected something tomorrow? So we were like, okay, we better come up with something. Zero. that's Tom's idea of a joke there, putting that as 0.0. Start collecting. If we don't if we don't do that, we risk loss anyway. And we witnessed a really interesting presentation by a colleague of ours, Savannah Campbell from the US, who made the point about VR 1.0, as she describes it, which is back in the late 90s and early 2000s, there was the first widespread commercial releases of VR hardware, a lot of them for gaming, and much of that is now lost. Some sort of computer museums have the hardware, but they failed to collect any of the software, kind of rendering the hardware as static museum objects, which is the last thing that we want for virtual reality experiences. We thought that we should get the artwork running at the point of acquisition, ideally on a dedicated and offline system. Many of the artists that we speak to at the moment, the closest thing that they have to a preservation strategy is get it running on a computer and don't let it go near the internet, because all of these runtimes, etc., they tend to, automatically update, and that can get you into this difficult cycle of needing to update other aspects of the work to get it working again. A disk image of this provides an excellent platform for emulating in the future. There's also a step here, which is maybe to test, as you export from your 3D engine, to test for different hardware at that point, so for different headsets, if available. I think that's something that we try and do at Tate, and that can highlight any peculiar quirks that you have in the work, and you might have the opportunity to sort of re-export at that point in various forms for Vive, for Rift, or perhaps using some of the new emerging open standards. To sort of gather as much documentation as possible, really, in conjunction with the artist, if possible, to describe how to set up the work, to describe how to display the work, and also discuss plans for display in the future. Get the production materials, and set up a software environment in which they can be accessed. As Tom was describing there in his section on migration, it's very probable that you might be able to open up that old project in a new form in an updated version of the 3D engine and re-export for some new hardware. And yeah, we've just been thinking a lot about how much effort it's taken me and Tom to get to this point of understanding of the preservation challenges, and how those feel like they're very much because of the commercial pressures and the way in which this field is evolving, how much of the work feels like maybe actually staying on top of the monitoring of the evolution of these technologies. And in doing that, perhaps identifying where you can make those crucial iterative steps of migration. And I think in general, the time-intensive things such as monitoring those technologies, we feel are like sort of best shared amongst institutions. So, we're very pro sort of sharing, and we're looking to make public all of our work on this project, published on the Tate and the Lumen websites. And we want to start, I think it's been mentioned here, but start a forum for sharing our approaches between institutions as we start to develop these ideas of what best practice are. So yeah, just really striving for that sort of collaboration and efficient work between us all. So please come and join us.